So now that we've done that investigation, let's just do a few practice problems. I'm not going to make you do all these here, but I want to make sure we can do two things, and it's going to be a two-way street. We have to be able to go from a graph to the actual equation, and vice versa, from the equation to the graph. Now, I think that going from the graph to the equation is actually quite easy, because all we really have to be able to do is identify what the vertex is and what the once you have that, and then whether it's opening up or down, you'll be able to determine um, where to go from there. So this first thing is, I would look at your graph and I would draw a point right here on the vertex, okay? And you look at that graph and you say, well, that's actually the point -1 comma -4. -1 comma -4. So that is your vertex, -1, -4. And by identifying the vertex, you've identified the most important information, right? You've identified what your H and your K are. So if you want to, you could write that off to the side here. You could say, hey, I now know that my H is -1 and that my K is -4, right? So when you identify the vertex, you get your H and K. That's really important. So if we're going to put this into the equation, f of x just means y, right? That's the same thing as y. So y equals, or f of x equals, the first thing that we're going to have to think about is what is our a value. And it's a little harder to tell what your a value is here as far as the actual number goes, but because it's opening upwards, right? Because it's opening upwards, I know that my a value has to be +1, okay? It might be +2 later on in the game, but right now it's going to be +1. So we know it's opening upwards. We then have a set of a binomial, right? And inside that binomial, we have x. And then here's where a lot of people make a mistake. A lot of people go, okay, I know that h goes inside the parentheses. And so they go, h is -1, and they put a -1 there. But you have to remember, when it's in the equation, it's a hypocrite. It's saying it's the opposite of who he truly is. So since h is -1, it actually in the equation is +1, right? It's going to be a +1. And so let's keep going here. We have it's squared, and then we have our k value, but our k value is the same. It always tells the truth. So our k value is -4. That's it. That's your equation. 1 times the parentheses x plus 1 squared minus 4. You can ask yourself what the y-intercept is. That's not as much of our focus right now. But if you could, it's no problem. Your y-intercept is right there. So that's 0, -3, right? And then, but a more important question is the domain and the range. We started talking about domain and range in your last lesson when we looked in at parabolas in standard form. Remember, the domain is always the same answer. It's all real numbers. That's that fancy R, right? It's all real numbers. In this case, for our range, because our parabola is opening upwards, right? Our parabola is opening upwards. That means our range is going to be y is greater than or equal to. Greater than or equal to is always when it's opening up. And then it's always the k value. So our lowest point, our k value, is -4. There's your range of the parabola, okay? So hopefully that's making sense how to go from vertex, from the actual parabola, to an equation in vertex form. We'll come back and look at standard form and solutions later if we need to. Um, for this one, I'm just going to kind of show you real quick. Notice my parabola is at +1, 4. So then when I created my equation, it was -1, +4. But because it's opening downward, see how we're opening downward? That means that my a value needs to be negative. So my a value is a -1 in this case. My domain hasn't changed, all real numbers, but my range is going to be less than, since we're opening downward, it's going to be less than, in this case, less than +4. So the only other thing that I want to focus on before we move on to the other direction, figuring out how to go from an equation to a graph, is this idea of max and min, right? So a maximum and a minimum all depends on which direction is opening, right? So because we're opening up in this case, that means we have a minimum value. That means we have a minimum value. So our minimum is our vertex, but that's our minimum. So don't be careful there. Some people think, oh, up means max. No, no, no. Up, because it's opening up, it doesn't have a max. It has a minimum. But if it's opening downward, that means we do have a maximum. We have a maximum point and we have no minimum because it goes infinitely downward. Okay? Let's go the opposite direction here. And instead of me giving you the graph, I've given you the equation. So I've jumped down to number 5. So the equation says x minus 4 in parentheses squared minus 1. So what the most important thing to do here right off the bat, I'm going to zoom in just a little bit, is to identify what your h and your k are. Right? So I'm going to write down h, right, and k over here. And then we're going to say what these values actually are, right? So my h value is the tricky one. What do we see? We see -4. We see x minus 4. So h is actually positive 4 because it's the opposite of what we see. For my k value tells the truth, right? The k value tells the truth. So we see -1. That's who it truly is -1. And by identifying what h and k are, we've just found our vertex. 4, comma, -1. That's our vertex. All right? The next step here gets a little bit tricky because if we're going to find the actual graph of this parabola, we need to be able to find a few more points. Okay? So to find a few more points, we're going to do something we did back in standard form, and we're going to create an XY chart. So I'm just going to really quickly create a little XY chart right here where we have some space. And just like we did last time, the vertex goes smack dab in the middle for -1. And just like last time, we do one step forward and one step backwards. So one step forward would be 5, and one step backwards would be 3, right? Now we can't do that on the y side. What do we do to find the y? To find the y side, we take either 3 or -5, not both, because remember it's a buy one, get one free deal. We take one or the other, and we plug it back in to the equation, right? We plug it back in for x. So I'm actually going to take, I know I drew the arrow from 3, but it's actually going to be easier to use 5, right? Because then we're not going to get a negative number. I'm going to take that 5, I'm going to plug it back in for x. So if you need to, we can do a little bit of math over here. It's going to be 5 minus 4 in the parentheses squared minus 1. 5 minus 4 is just 1. 1 squared minus 1 is 1 minus 1. Oh, look at that. It's 0, right? So that means when we plug in 5, we get 0. And when we plug in 3, we get 0, right? It's a buy one, get one free deal that when you've already plugged in the 5, you get the reflected point, the symmetrical point for free. So we now have 3 points, and those 3 points are enough to graph our parabola. I'm going to start by graphing our vertex again. So we're going to go over to 4 and down to -1. This is the hard part on a computer screen, is staying accurate. And then we have 3, 0, and 5, 0. So 3, 0 is going to be right here, and 5, 0 is going to be right here. Whoops, that one was not good. Let's try that again. Okay, it's still ugly, but it'll do. Okay, so at this point, we can now take our pencil, pen, whatever, and we can draw the best parabola we can. It doesn't need to be pretty. We're not artists here. This is just the best parabola we can. There we go. You've actually graphed a parabola, right? We graphed our vertex, and then we found 2 points. We only had to do the work for one, but we got 2. One to the left and one to the right. That's how we graph a parabola when we're in vertex form. So there's a few others there for you to practice. You can always look at the completed notes if you want to see how those are done. Keep up the good work. We're proud of you.